algorithms, or we talk about in sense of computer science, when we talk about efficiency, we intend to say that how much time it takes or how much space it takes, because you are paying money for time, you are paying money for space. If you're using a lot of storage, then also you are paying money, and if you are taking a lot of time, then also you are paying some money. So whenever we want to optimize something, we want to optimize for time, we want to optimize for space. Is that clear?
Yes, sir.
So when we say we want to write a good algorithm, goodness of algorithm is in terms of time and space. How we will measure time and space, that is a different topic, but it will be in context of time and space. Kabhi kabhi, if in order to optimize time, we have to give some space. In order to optimize the space, we have to give some time. Sometimes there is a trade-off. Sometimes you can decrease both. If you're able to decrease both, then very good. If both are high, then it is very bad. Sometimes we can pay for space, but we don't want to pay for time. Sometimes we can pay for time, we don't want to pay for space. But we will always be playing with these two. That one thing you should keep in mind. Okay, so it is not just time complexity, it is also space complexity. पहली बात तो ये हो गई, ठीक है, इतना तो हमें समझ में आ गया. ठीक है, अब how to evaluate and program. So if you talk about CPU usage and time taken for execution, okay, this depends on many things. This will depend on the hardware, this will depend on the software environment. Okay, so if I'm having algorithm 1 and algorithm 2, okay, and I'm running it on PC1, running it on PC2, one is taking 10 seconds, other is taking 15 seconds. It is possible that the PC on which it is taking more time, there the hardware is of lower configuration, or software is little bit slower, or the operating system is not very good, or the memory is not very good, the hard disk is poor. Okay, so can you compare that way? Will it be possible for you to compare it that way? It's not a fair comparison. There is one more demerit. The other demerit is that if you're trying to evaluate an algorithm based on the time taken for execution, for that you have to execute it, which means you have to write it, which means before writing, if you're going by this philosophy, then before writing the code you cannot evaluate it, which means you have to write every single line of code, and then you have to run it, and then you have to decide how much time it is taking. That's also a problem. And it is also difficult to segregate it from the impact of or the interference of the hardware and software. That whether the algorithm that you wrote, that is good, or your hardware itself is so good that it is taking less time. Are you guys following what I'm saying?
Yes.
Okay, so instead of doing this, the approach that we take is that we try to estimate, and keep in mind we are estimating. Okay, nothing is accurate. We are estimating, we are getting a rough ballpark understanding of how. So this is not correct approach, this is not correct approach, this is the correct approach. Okay, so we say that how many primitive steps taken in the algorithm, and how it scales with respect to input. Okay, this is how we will say. So even before writing the code, even before we write the code, even if we know the algorithm, if we know the pseudocode, or if we know the high level understanding of what we are trying to write, we can always calculate how many primitive steps, how many steps it will take for me to complete that algorithm. Okay, and what is this primitive steps? We will ask, what is this primitive steps? Okay, primitive steps means one unit in a computer calculation. So some of you were asking me that, sir, why pointer arithmetic is you are saying constant time? Okay, so we'll say that when the CPU is working, or CPU is doing some work, okay, what is one unit of work? So there are certain steps which are said to be primitive steps. For example, reading something from a memory. You read a memory, or you assign some value in a memory location, or you do one arithmetic calculation. Okay, and few other steps are there. So all these steps are labeled as primitive steps, which means it is one unit of work. And we will say in our algorithm how many units of work is happening. Those unit of work is called as primitive steps. Okay, so using this analogy, using this understanding, can we evaluate our algorithms? Okay, so let us do that. Let us do that analysis now. Okay, so what was our algorithm one? Let me bring it down if possible. All the three algorithms, let me bring it down. Okay, so this was algorithm one. So can we calculate how many steps it is taking? Suppose we have not written the code. We have not written the code. We have just written the pseudo code, or we have just understood how we are going to do the work. Okay, so let me take like this. Okay, it is 10, 15, 18, 12, 16, 15, and 12. This is a very, very important topic. Okay, please pay attention, all of you. So the person who suggested this algorithm, he told me that I will take the value of 10 and I will compare it with 15, 18, 12, 16, 15, and 12. So how many comparisons I did? 10 to 15? 1, 2, 3, 4, 5, 6. So I took 6 steps or 6 comparisons. Okay, one comparison will take it as one unit of work or one primitive step. Are you guys following me? Guys, yes or no? It has become very silent, you guys. Okay, then we will go to 15, and 15 also we will compare to everything. So how many steps will take? 18, 12, 16, 3, 15, 4, and 12, 5. So we'll take 5 more steps. Then we will go to 18. 18 also will compare with 1, 2, 3, 4. Then we'll go to 12. Again, we'll compare with 3 more elements. Then we'll go to 16, we'll compare to 2 elements. Then we'll go to 15, we'll compare to 1 element. So it is 1 plus 2 plus 3 plus 4 plus 5 plus 6. So if there were 1, 2, 3, 4, 5, 6, 7 elements, then we had to do this many steps. Or we'll say input size. Input size is equal to 7. Then this much work we have to do. If the input size was, instead of 7, if it was 70, then what would have been the situation? 69 plus 68 plus 67 plus dot 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 plus 3 plus 2 plus 1. Are you guys following? Okay, if the input size becomes n, then what this will be? N minus 1 plus n minus 2 plus dot 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 plus 3 plus 2 plus 1. So this is what? If you do this, then this is what? This is n into n plus 1 by 2, which is equal to n square by 2 plus n by 2. Okay, so we will say that this is of the order of n square, which is the biggest term. Which is the biggest term. What does this mean that this is n squared? इसका क्या मतलब हुआ? n squared का क्या मतलब हुआ?
Double of the given.
What is the implication of n squared? Roughly, again, I told you in the beginning that we are doing a rough analysis. This is also called as asymptotic analysis. It means that the number of steps is of the relation square of number of input, which means that if I give you an array of size 2, then you will do 4 operations. But if I do give you an array of size 3, then it is 9 operations. If I give you an array of size 10, then you will do 100 operations. Correct? If I give you 50, then you will do 2500. And if I give you 100, then you will do 10,000. So you see, it is increasing very fast. Here I'm increasing slowly, but here it is increasing very fast. So is this good algorithm or it is bad algorithm?
So that is bad algorithm.
It is bad
but
algorithm. Imagine
yeah.
that this is the money that you are paying for every operation. Suppose for every operation, suppose you have to pay money 1 rupee. Will you be able to pay this much money? For 3 steps, it is 9. Imagine this is the mileage of your car. For 2 kilometers, it is taking 4 liters. For 3 kilometers, it is taking 9 liters. 100 kilometers, it is using 10,000 liters. Will you drive that car? Did you understand, guys? This is most important thing that we have to understand.
So how input 2 should take the 4? Because 2 means 2 comma 1, right? 2 steps. But how is n square? The input is 2.
Here
But
only
it is
I explained it. No, same thing I explained.
Yeah, yesterday in the formula I got it, but I have
roughly,
only
Baba,
2.
this is rough.
Oh, rough, okay.
Roughly, say you are having 2 and 4. So how many steps it will take?
Yeah, 2 steps,
Suppose
right?
it is taking 2.
Yeah,
Okay. If you take 2, 4, and 3, then how many operations it will take?
3 steps though. 3
It
steps.
will take 2 steps. 2 and 4 you will compare. 2 and 3 you will compare. And then 4 and 3 you will compare.
Oh,
So
8
2
steps.
plus 1 is equal to 3 steps you are taking.
No. 2 plus 2, 2 plus 4.
2 and 4 you will compare. 2 and 3 you will compare. 2
Yeah,
steps.
correct.
Then 4 and 3 you
Yeah,
will compare. So 1 step. How
correct,
many comparisons you are
yes.
doing?
3 steps or
3 steps you are taking. If you take 3, 4, if you take 3 input size, 2, 4, 3, and 2, then how many steps you will take? You will first compare 2 with 3, then you will
3,
compare
yeah.
4 with 2,
2, yeah.
or basically you can say 3 plus 2 plus 1.
Yeah.
So how
5
much
and
this
6
is?
times.
This is
6
6.
steps.
If you keep going, if you are having 10 elements, then how much you will take?
Okay, it's getting the square back.
9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1.
Yeah.
What will be the sum of this? And then you plot it. You will get a graph like this. So this is y is equal to x square. This type of graph you will get.
Oh, okay.
Is this good or is this bad? See, it is exactly not n square. Actually, it is n square plus n by 2. So actual number of steps is 2 into 3 by 2. So it is 3. But if you see how it scales, that will be of the square order. Here I've taken an estimate. N square plus n by 2 ko I estimated to be n square. Are you guys following? Okay, let us talk about algorithm 2. Algorithm 2 we cannot talk because sorting takes some steps which we don't know right now. So algorithm 2 को आप अभी side में रखो. Algorithm 3, let us come to algorithm 3 and compare it. Okay, if we do the similar analysis for algorithm 3, we are having 10, 15, 18, 12, 16, 15, and 12. Okay, and the solution that the person gave was that we'll read 10 and we'll put it in a dictionary. Okay, then we'll take 15 and we'll put it in a dictionary. Then we'll put 18 and we'll put it in a dictionary. So how many steps you are going to do? If there are 1, 2, 3, 4, 5, 6, 7, if the input size is equal to 7, then how many steps we are taking here? Are we taking 7 steps? We are putting one thing in a dictionary. Nothing else we are doing. Guys, are you following or not? If the input size, if it becomes 70, then how many steps we'll take? 70 steps. If the input size becomes 700, then how many will take? 700 steps. If it becomes
Yeah.
1000, then how many steps will take? We'll take 1000 steps. So does this look better compared to the previous one? The previous one was looking like how? If it is 7, it is taking 49 steps. If it is 70, it is taking 4900 steps. If it is 700, then it will take 49, 1, 2, 3, 4. 49, 4,90,000 steps. If it is 1000, then it will take 1, 2, 3, 4, 5, 6 lakh, 10 lakh steps. If you have to pay money, which one will you prefer? Or I gave you example of your car. If that many liters of petrol it is using per kilometer, then which one will you prefer to pay? Second one means this one, no? So did you understand how we estimate the efficiency of an algorithm? But if I tell you one more thing, in the second solution, if we talk about space, did we take some extra space here? We took extra space also, right? Because we have to create a dictionary. So we also have time complexity and we also have space complexity. So in the first solution, we were not using any extra space, but we took extra time. Here we are taking less time, but we are taking some space. So time complexity is linear. Space complexity is also linear. Because if there are 700 elements, then worst case, you have to store all those 700 elements in the dictionary. Again, keep in mind, this is worst case. Always it will not be. Sometimes the first element itself is duplicate. So there only the program will end. But whenever we talk about efficiency of an algorithm or goodness of an algorithm or a data structure, we always think about the worst case. So if you learn about it in theory, if you are learning it in a college, if you're learning data structures in your college lecture, from your college textbook, there they will talk about best case, average case, and worst case. But in practical life, we always talk about worst case. Rarely we will talk about best case. Rarely we will talk about average case. Normally we will talk about worst case. Almost always we will talk about worst case. Guys, are you following?
So can you explain the space complexity though? That one more thing.
Space complexity means we are taking some extra space, right? If we are
Yeah.
having this one, if we are doing this. So I'm taking this 10. So suppose this is the warehouse that has been given to me, in which
Yeah.
we are having 1, 2, 3, 4, 5, 6, 7. Okay. So in order to find out whether there is duplicate or not, I am renting one more space. in which I will make this dictionary.
Okay.
And in this dictionary, if you are assuming it to be a warehouse, there also we will store this 10, we will store this 15, we'll store this 18, we'll store 12, we'll store 16, right? So worst case,
Yeah.
if there are n elements here, we have to store n elements here also. So we
Okay.
are not, we are, if you have to pay money for the algorithm, then you have to pay money for the space. We are paying less money for time because we are doing only 7 steps, but we are also taking 7 steps, 7 space units in memory also. Someone is saying, what is the space complexity in the first one? So in the first one, we are not taking any space, extra space. We are not taking any extra space. So here, if you talk about time complexity,
A space complexity means
space complexity, time complexity, here we will say it is quadratic. And space complexity, we'll say constant. Constant means we are not taking any space. Or whatever space we are taking, it is constant. The space is not growing with input size. Manas is saying if we are just using duplicates logic and return, can't we just have another list instead of dictionary to store, as we are not increasing count? Just we see if number is already available. Manas, I did not understand. Can you repeat? If we are just using duplicates
Yeah.
logic and return, Manas,
Yeah.
क्या बोल रहे हैं समझाइए जरा.
So for example, here in this case, we have frequency dip. What we are not doing like 10, 1, 15, 2. What in the logic it is written, if any number is available, then just return true. And if I just checking the duplicates, we can just use list instead of dictionary, right? Just put one number.
If you use list instead of dictionary, यहाँ पे आप बोल रहे हो.
Yes.
ठीक है, तो अगर लिस्ट यूज किया तो क्या होगा?
आप एक नंबर अपने वैलिड नंबर डाल दिया वहां पे, फिर आप दूसरा नंबर जब चेक करोगे तो आप लिस्ट में खाली चेक कर लो कि वो नंबर अवेलेबल है.
ठीक है,
अगर नंबर अवेलेबल है तो वो डुप्लीकेट हुआ, प्रोग्राम वहां से एग्जिट हो जाएगा.
ठीक है, वेरी गुड. बहुत ही वैलिड बात आपने बोली है. ये बात शायद किसी और ने नोटिस नहीं किया. व्हाट मानस इज सेइंग दैट यहाँ पे डिक्शनरी ही क्यों यूज करें, यहाँ पे लिस्ट भी तो यूज कर सकते थे. तो ये जो लाइन हमने यहाँ पे लिखी है, ये जो लाइन यहाँ पे हमने लिखी है, यहाँ पे डिक्शनरी हो ऐसा क्यों जरूरी है?
Can I explain English, sir? Little bit.
हाँ, he's saying why did you create a dictionary? You could have created a list. यहाँ पे ये डिक्शनरी क्यों बनाया, ये लिस्ट बना देते. Is that what you are saying, Manas? Have I understood correctly?
Yes.
तो क्या होता है? अच्छा, ये क्वेश्चन को हम लोग यहाँ पे लिखते हैं. Why dictionary and not list for duplicates? This is a very good question, क्योंकि हम लोग डेटा स्ट्रक्चर के बारे में पढ़ रहे हैं, तो ये बहुत ही अच्छा क्वेश्चन है डेटा स्ट्रक्चर को थोड़ा समझने के लिए. फॉर डुप्लीकेट्स, ठीक है, इसको मैं एड्रेस करता हूं. बट अदर देन दैट, हैव यू गाइस अंडरस्टूड एवरीथिंग? Space complexity, did you understand, guys? I think someone was asking. Guys, tell me, who did not understand? Anyone has having any question till now? What we have done till now? यहाँ पे मैंने थोड़ा गलत लिख दिया. ये इसका टाइम कॉम्प्लेक्सिटी नहीं है, ये इसका टाइम कॉम्प्लेक्सिटी है. या यहाँ पे मैं लिख देता हूँ, टाइम कॉम्प्लेक्सिटी इज क्वाड्रेटिक, स्पेस कॉम्प्लेक्सिटी इज कांस्टेंट. तो क्वाड्रेटिक होता है उसको हम लोग लिखते हैं O of n स्क्वायर्ड, ठीक है, और कांस्टेंट होता है उसको लिखते हैं O of 1. ये O क्या होता है इसके बारे में हम लोग वी विल डिस्कस नाउ. ओके, एंड एल्गोरिथम 3 का अगर टाइम कॉम्प्लेक्सिटी हम लोग बोले तो दिस इज लीनियर. Today is also Diwali or what? People are bursting crackers outside my house. Oh, Chhat ke liye, acha, correct. I will also go and burst then.
Where are you?
I'm
which
in
city?
Hyderabad.
Then it's a Nagal Chauthi or something. There is a snakes.
What?
Nagal Chauthi. There is like after Diwali they do an snakes
What?
festival.
Just tell me the name of the festival. I just need excuse to burst crackers. Nagula Chaviti. Okay, fine. Did you guys understand time and space complexity? Okay, I will summarize. Time complexity is basically how many steps you are taking in your algorithm and how those number of steps are growing with the growth of input. If your input is growing slowly and your number of steps is growing very fast, then that is a bad algorithm. Now, what is slow, what is fast, all of these are vague terms. We will formalize it a little bit. Okay. We'll talk about big O notation.
So do we give the preference to time or space or
Depends.
both? Depends. Depends on the
Depends.
problem.
But you have to
Yeah.
justify both. If you are in an interview, you have to justify both.
Mhm.
That I have written this solution. This solution is having this much space. This is having this much time. Sometimes in the question, it will be written that you have to use constant space. If you remember the question we were doing for reverse string, in the question it was written that you have to do it in constant time. Sorry, in constant space. Even if it is not mentioned, whenever you write an algorithm, you have to keep an eye that how much time I'm taking, how much space I'm taking. Is it possible to take less time? It is possible. Is it possible to take less space? Okay, and you have to justify that I have written this algorithm. It is O of n in this one. It is O of n in space. If you ask me for constant space, then I have to go for O of n square in time. So these are the different trade-offs. So that you have to explain. Okay, before going to big O notation, okay, big O notation you already know, you have understood already. I will just give you definition, but before that I will answer this question that why did we use dictionary and why did we not use list? Okay, why we did that is because dictionary is a data structure, okay, which is called as a hash map. Okay, so in a hash map, if we want to check membership, it happens in constant time. Okay, and if you are using a list, if we are using a list is based on a array. So here if we do check membership, which means whether an element is existing in a list or not, if we have to check, then it is, if we have to check membership, it is linear time. Which means that suppose you are having a dictionary. Okay. 10, 1, 15, 1, 16, 1, 17, 1. Suppose you have a dictionary and you want to check, this is my X. Suppose you want to check that 15 in X. Okay, this you can do in constant time. In one step only, we can find out whether 15 is existing in X or not. Why we are able to do that? That you will understand when we learn about hash maps. That how hash maps work. Because hash map is also a data structure. So just like how in array, we are able to access any element in constant time. Similarly, because of the way it is stored in the memory. Similarly, a hash map is stored in such a way that if we want to check a membership, then we can do that in constant time. How? That we will see. But if you have to do it in a list, suppose you are having a list like 10, 15, 16, 17. A list जो data structure है, if you have to do it, if you have to check membership in a list, suppose you want to check 15 in X, suppose X is this, then you have to go and check. पहले 10 से कंपेयर करेंगे 15 और 10 बराबर है कि नहीं, नहीं 15 से जाके चेक करेंगे हाँ है, ठीक है. So you have to go and compare with every element to find out whether that element is existing or not. So that's why it becomes a linear time. So अगर linear time हो जाएगा, if that becomes linear time, if this line of code will be O of n if it is a list, but it will be O of 1 if it is a dictionary. That's why we are using a dictionary, or we will use a set. You can also use a set. So many people were giving me a solution, alternate solution to this, which will be you can compare length of nums is equal to length of set of nums. Because length set of nums will give you all the unique elements in the list. So if there are no duplicates, then all the length of unique elements will be equal to the length of nums. So you are using a set. You can use a set also, you can use a hash map also, both the solutions are similar. So this also you can use.
So can you repeat this one? Alternate a length num equal to length set.
Acha.
It is order up and I understood, sir. But cache map and list of set is how is one?
List and hash map.
How is it order up one?
We will understand. No, today's only first class. Hash map is a separate topic. We'll learn about it.
No. You said that it is order up one, right? Dictionary is order up one.
Order, I will tell you. I'm going to start Digo notation. We'll talk about it.
Okay.
So he's asking why that set wala question. No. So what was the question? 10, 15, 18, 12, 16, 12. Okay. So if you learned about sets, right? What does set do as a data structure, as a data type in Python?
Removing the duplicates.
It stores unique values.
Unique values.
Correct. So if I'm having nums is equal to 10, 15, 16, 12, 15, and 30. So if you do set of nums, what will you get? 10, 15, 16, 12,
30.
and 30. Okay. So what is the length of this? 1, 2, 3, 4, 5, 6. And what is the length of this?
5.
5. Why 5? Because one element was duplicate.
Yeah.
But if there were no duplicates, then length of this and length of this will be same.
Yes, correct.
Correct, no?
This order of one, n only there.
You can do length of nums equal to length of set of nums. If this is true, it means no duplicates. If this is false, means there are some duplicates. At least there is one duplicate. Fine.
Just a quick question here.
One more thing, just internally set also
Manas is
using
saying set will be like O of n as it needs to traverse. No, set also works on the same concept as dictionary. Here also we can check membership in constant time. Tell me what you were saying.
Sir, I'm just asking it, inside the set also it is using some kind of data structure to store.
Correct.
Because internally also it using some kind of comparison and storing the value.
Correct.
Right. So what that would be? It's like order or not? I just like checking. So
in a
would we
set,
need- yes.
in a set we use a concept of hashing.
Okay.
Okay, so we'll talk about that. I don't want to discuss that now because it is a separate data structure. So when we learn about hash maps or hash tables, that time we will discuss it. But for now, just know that if you're creating a set, 10, 15, 16, 20, okay, or if you're creating a dictionary, and if you want to check that 15, suppose this is X, you want to check 15 in X. So this will happen in linear time. Sorry, constant time. So here, if there are 4 elements, it will take the same time. If there are 4,000 elements, then also if you want to check 15 is existing or not, it will take the same time.
Sorry, Ram, just for understanding,
So
when we say length, suppose we say length of list of n equal to length of set of n, then anyhow it has to perform all the operations for all the numbers in that particular case, right? At
Sorry.
least once. If we suppose length of n, that means we are just taking all the length of whatever is in the list. And when we convert it to the set, then again it needs to traverse at least all. For example, we have 10 numbers there and we have 2 duplicates. But again, it has to go through all the 10. So doesn't it mean that it is basically O(n) at that time with this particular logic? Length n equal to length of set of n.
You're saying this one?
Yes, here it will be O(n), right? Because
Let it be
anyhow
O
it
of n.
Yeah.
Even
Sorry,
if it is
length
O
of-
of n, your entire solution itself is O of n, right? This solution we are saying is O of n only.
Okay.
So first you are iterating this entire list. So you are taking n steps. And suppose this is also taking n steps where you are doing that length of nums. So n plus n will become 2n. So 2n is also n only.
Got it. Got it. It's order which is mentioned.
It is
N
order,
plus n
means
means
how
two.
it is scaling.
Okay.
Scaling is in the sense of whether it is linear or not. So 2n is also linear, 3n is also linear, 10n plus 4, that is also linear. All of them will be straight lines only, no? हमें प्रॉब्लम तब होगी जब वो n स्क्वायर हो जाए या log n हो जाए, करेक्ट, और n क्यूब हो जाए, then we will be worried. If it is n squared plus 2 or log n plus 30 or n cube plus 4n square, that we don't bother. We are bothering with which is the highest term. Is it clear?
then
Yes,
what is
thank
the
you.
difference between, sir, what is the difference between constant and order of n, sir? Both
What
the
is
same,
the
right?
difference between?
Constant and order of n, linear. The both are same or different, sir? Constant
No,
time
how
and
it is same, Baba? If you are doing constant, suppose
Yeah.
this is a graph. I don't know how much math background you have, but suppose this is time taken and this is input. If it is constant, it means it is constant like this. If your input is 10, suppose this is 500 millisecond. If it is 10, then also it is taking 500 millisecond. If it is 100, then also it is taking 500 millisecond. If it is 1000, then also it is taking 500 millisecond.
Okay.
Okay,
So,
this graph should
yeah.
not be 1000. Let me make it 10, 20, and 30. But if it is linear, that means it will be like this. When it was 10, then it was taking this much time. When it is 20, then it is taking this much time. When it is 30, then it is taking this much time. So definitely this is O of n, this is O of 1. So which one is better?
Open is better.
O of 1 is better. But if it is O of n squared, suppose, then it will become like this. Correct, no?
Okay. No, in the above, the same, I understood in the graphical manner, but in the above examples, right, x equal to 10, 15, 16, 20, like that, in the above examples, no, it is a constant time.
Sorry, where?
No, the same, x equal to 10, 15, 16, 20.
Uh-huh.
You are saying that it is a constant time, right? How
Correct.
does it is a constant time?
I'm saying the way this is stored,
Hmm.
the way this is stored, the way this data structure is stored, if I want to check 15 or 16 is present in this set or not, I can do it with just one calculation.
Yeah, but it's comparing, right? It's one by one, you can
It is
iterate and
not
compare.
comparing. That's what I'm saying. It will
Mhm.
compare in a list. It will not compare in a set. If it
Okay.
was like this, 10, 15, 16, 20, then if you're asking 15 in X, then this is linear time.
Oh, okay. So one
This
by
is a
one
list.
movement.
This is a set, Baba. This is a set.
Got
This is
it,
a
got it.
list.
Okay.
List and set are very different things.
Okay, understood.
In a
if it
list,
is
when you are
list,
comparing,
yeah.
comparing, then this 15 will go and check with this, then will check with this, then it will check with this, then it will check with this.
Yeah, correct. Makes
But in
sense,
a set,
yes.
it does not have to go and check with every element. It will directly find out.
Okay.
Okay. Anyone else
So-
having any other question? Okay, today we'll stop. It is already 7 o'clock. Big O notation already you know. It will be 5 minutes. We will cover it in the tomorrow. Then we will start.
So
Big O
n square
notation is
is.
basically, if it is linear,
Mhm.
we say O of n. O of n means function of n, means it is growing linear way. If it is quadratic, we say O of n squared. Okay. Cubic, we say O of n cube. Okay. Log, we say O of log n. Okay. Constant, we say O of 1.
So everything the time complexity there.
Same logic will go for space also.
Space also. Okay.
Okay. Here O means, you can say order also, but O actually denotes big O. It is written as big O.
Also,
There is also one omega and there is also one theta. There is omega also and there is one theta also. Okay. So these two are also there, but normally we denote with big O. This is the worst case. Okay. There is a more mathematical definition of big O, but I don't want to get into the mathematical definition. We will make do with intuitive understanding of what is big O. Okay. And when we do more and more examples, it will become a little bit more clear. Guys, today's class, did you guys understand everything? Class is over. I will stay for some time if anyone has any doubt or anyone has anything to share. I will stay for 5 more minutes. Those who want to leave, you can leave.
Sir, theta and this mu, that are for like average or best or
हाँ.
like
एक average होता है, एक best case होता है.
which is best? Theta is the best, sir?
Sorry,
No, theta is the best or?
I am also forgetting. I think this one is the average case.
Okay.
This one is the best case. I will check and I will tell. We don't use it much, so I have also forgotten. But normally we will use worst case always.
The logarithm is the 2 worse than n square, right? Logarithm.
हाँ.
No, log of n only is
The सबसे best is O of 1.
uh-huh.
After that, we have O of log n.
Mhm.
There are others also, but normally, practically, you will have O of 1, O of log n. Normally, you will have O of n, then O of n squared. Worst case will be O of 2n, O of n factorial. These are very bad. Okay.
So O of 1 is the best one. O of 1
O
or
of 1
O
is
of
least,
log.
means you are doing it in constant time. It cannot be improved more than O of 1.
Okay.
O of 1
Okay,
is the
log
best.
n.
Okay.
Then
So normally,
log n.
practically, I am telling you, practically, whenever you are writing solution in lead code, if it is O of n squared, someone is asking you to optimize it. You will say, okay, I can optimize it to O of n. If you are writing O of n and someone is saying you have to optimize it, normally O of n will become O of log n. Sometimes O of 1 can become O of 1 also, rarely. But normally O of n will become O of log n. ठीक है. O of n के बीच में एक और होता है, which is called as O of n log n. So normally just sorting algorithms we are learning, that is O of n log n. So that is also there. So these are commonly the ones that you will encounter. Now theoretically, if you study big O, this concept, you will have a mathematical definition of big O, plus you will have under root of n, k, n square root of n, all those things will be there. Okay. So don't have to bother about that. Practically, when we are solving problems, we will always have 4 or 5 time complexity only. n squared रहेगा, n रहेगा, log n रहेगा, 1 रहेगा. When we are learning to sort and when we are learning about heaps, that time you will come across n log n. But other than this 5, 6, usually you will not find other complexities.
Sir, when we are going to optimize the code, how would we know that whether it is reached log n or whatever?
कैलकुलेट करना पड़ेगा. अभी कैलकुलेट करके बताया ना आपको. जैसे ये हमने कोड लिखा था. इसमें मैंने कैलकुलेट किया ना कि ये n स्क्वायर्ड है,
n square a square.
इसमें कैलकुलेट किया ना हमने कि O of n है। अब कैलकुलेट करके तो बताया आपको। अब कल मैं log n वाला एग्जांपल भी दे, आई विल गिव यू log n वाला एग्जांपल भी, n क्यूब वाला एग्जांपल भी आई विल गिव यू, बट दिस इज हाउ वी कैलकुलेट। If you have written the code, you know how many steps, where what steps is happening. Based on that, you can do one dry run and you can simulate it. कि अगर दो इनपुट है तो कितना स्टेप्स लग रहा है, 4 होगा तो कितना लगेगा, 10 होगा तो कितना लगेगा, कैसे ग्रो हो रहा है, वो ग्रोथ का पैटर्न आपको दिख जाएगा।
So mostly we can also relate to the time, sir. But space-wise also, how can we do with n and order of constant time or n, order of n? The space complexity that.
Why do you need library? In order to use the library, you will have to write the code, no? Algorithm is in my mind only.
Okay.
In my mind only, I am calculating, no? I don't have to write the code in order to find that big O. That is the main advantage.
Now, for example, if we look at any problem, right, and how can we think it about which is taking this much time and is not good for
Practice,
the company?
practice.
Practice. Okay.
Practice. First, you will write one solution. That is the brute force solution. Okay.
Uh-huh.
Brute force solution usually will be very inefficient. Sometimes brute force solution is the only solution, but sometimes there is a better way of doing it. I gave you the example of reversing the string, if you remember. We were doing it in O of
Yeah.
n squared. Then I showed you the same example with O of n also.
Yeah.
Here also I gave you one solution with nested loops, which was O of n squared. Then somebody gave a better solution, which is algorithm 2. Algorithm 2 is O of n log n actually. So
Yes.
algorithm 2 is better than 1. Then we thought little bit more. Then we came up with algorithm 3. It is better than algorithm 2 also.
The algorithm 3 is also order of n only. Yes.
It is order of n. 2 is n log n.
Yeah.
So you see, 3 solutions, all of them are incrementally better than each other. But in algorithm 1 and 2, we are not using space. But in 3, we are using space. So time complexity came down, space complexity became little bit more. Now all these
More,
things
yeah.
you have to negotiate. Every question will have different dynamics.
Okay.
You will do practice, then you will get to know. See, common, whenever you are using dictionary, membership check, automatically your brain will say, okay, O of 1. List में काम कर रहा है ऐसा होगा, string में काम कर रहा है ऐसा होगा. वो practice करते करते वो अपने आप आ जाएगा. Manas is saying, do we have any library which can provide these details about complexity? I don't think so. See, again, if you want a library, that means you will have to write the code. The idea is that we should not write the code. In an interview also, all this discussion will happen before writing the code. First, you will explain your approach, then you will do the dry run, then you will explain time complexity and all. Writing code will come in the end. So even if you have a library, it's not going to help you much. Normally, complexity we will calculate using hand, means we will not use any library or automation like that. We will use our own sense. And that's why we are doing approximate. We are not doing exact. Roughly कैसा grow हो रहा है वो दिखना है कि linearly grow हो रहा है या quadratic grow हो रहा है. Rough estimation तो हम लोग कर सकते हैं. It is like back of the envelope calculation. Guys, any other questions? Can I go?
Yeah. So can we think it? Can we think like if we are going to use a 3 for loop and it is an n cube, right, sir?
Yes.
Yeah, n cube based
But
on the
why n
loops.
cube? Do it and see.
Uh,
Don't
how many?
memorize it.
How? Okay, okay.
Do it
Yeah,
and see. Then
sure.
you will understand.
Got it.
We will do some practice tomorrow also. We will try to practice log n wala example, n square and log n wala example. And then you will get understanding of all 3, 4, 5 complexities. Then we'll start with arrays also.
Okay. So what is tomorrow agenda, sir?
Tomorrow agenda, tomorrow we'll decide.
Okay, sure.
Can I go?
Yeah, I think it's almost 4 hours, three and a half hours, I think.
Anyone having any questions? Write it down and tomorrow we will discuss. Okay. Chalo. Bye guys.
Right, thank you, sir. Thank you.
Bye. Thank you. Bye.